Explain breakpoint chlorination. We have studied that chlorination is a method used for disinfecting water. The amount of chlorine required for disinfecting water depends upon the inorganic and organic impurities present in water. During chlorination, two types of chlorine are present in water. Combined chlorine residuals like chloramines and free chlorine residuals like Cl2HOCl. When chlorine is added to a sample of water and its amount is estimated after a few minutes, it is found that the available chlorine is not equal to the amount of chlorine added. The results obtained can be depicted graphically in the form of a curve, which consists of 4 stages. Let us discuss about these 4 stages. Because chlorine is an oxidizing agent, in the first stage it oxidizes organic matter and other reducing agents like ammonia, ferric ions, hydrogen sulfide, etc. Here all the chlorine added is consumed, and there is no residual chlorine. In this stage, phenol is oxidized to chlorophenols, which gives a peculiar odor to water. As the amount of chlorine is increased, in the second stage, there is steady increase in the amount of residual chlorine. This happens because the chlorophenols react with ammonia present in water to form chloramines. These chloramines act as free chlorine reserves, which helps in killing organisms which were not destroyed in the first stage. When the dosage of chlorine is further increased, the complete oxidation of chloramines and chloro-organic compounds takes place, which in turn utilizes the chlorine, and hence free residual chlorine also decreases and reaches a dip at the end point of the third stage, represented by a tip in the curve. At the end point of the third stage, represented by a dip in the curve. This appearance of chlorine at the dip or break of the curve is known as breakpoint chlorination. Usually at the breakpoint, all the tastes and odors disappear, resulting in water free from bad tastes and odor. Although here it should be noted that the free chlorine that becomes available at the breakpoint appears only after the demand for Cl2 by other reacting substances is met with. In the fourth and final stage, the highly persistent and powerful disinfecting action of free chlorine residuals destroy any other type of pathogenic organisms that might be still present in water. So it is clear from the curve that chlorination of water proceeds in 4 steps. Up to point A, chlorine oxidizes all the reducing compounds. From point A to point B, formation of chloro-organic compounds and chloramines takes place. From point B to point C, chloro-organic compounds and chloramines get destroyed. And from point C to point D, the pathogenic bacteria present in water gets killed, free residual chlorine increases. Hence, to use chlorine as an effective disinfectant, the chlorine dosage has to be slightly more than that at the break point.